Now, I would like to invite online participants. If any one of you have some questions, so first please raise your hand and then we can go turn to turn. Just like quick 1-2 questions because it won't take much of it. Any question from online participants? Yes, Isma, please go ahead.
Okay, hello, Professor Inki. Thank you for a very nice presentation, very informative presentation. So my question is from dual mode imaging system, which you have presented. So whenever we do some sort of imaging with metal lens, so we have one challenge with the focusing efficiency. So how you have overcome this challenge of focusing efficiency?
Yeah, that was critical point actually. You know, by satisfying these phase measure requirements for this dual imaging, at the same time, obtaining high transmission is very tricky. It's very difficult. So although we make our best fabrication technique, at the time our focusing efficiency is around 50 to 60%. So it was enough for just simple this imaging target imaging, but this low efficiency was critical for this bioimaging. So this simple cell, it's okay, but this kind of spiral cell, the imaging quality was not that significant. So anyway, to overcome this issue, we need to change the material metasurfaces. We can, we can really make high efficiency metasurfaces. So my former advisor, he used nanocomposite. So this titanium oxide nanoparticle and UV resin can be used for this high efficiency metasurfaces, where TiO2 metasurface can be also another solution. Yeah.
Oh, thank you. So whenever we use this periodic type of structure, they are inherently sometimes when we try to embed the dual functionality into single periodic metal lens, then they have some sort of 50% theoretical efficiency limit. And in that case, how we can overcome this thing, or what could be the possible solution for this?
So anyway, it doesn't have to be, this single nanostructure, it has a dual function. It has different phase delay between LCP and RCP. So it doesn't have to be always less than 50% efficiency.
Okay, thank you.
Thanks, Isma. So Dr. Nasir, you raised your hand. So if you have some question, please go ahead.
Thank you, Professor Inki. It was a very nice presentation and it was really informative. So my question is basically high numerical aperture and efficiency relation. So I have observed that as we just increase the numerical aperture, the focusing efficiency, it decreases gradually because the focus point come closer to that, and the constructive interference, it basically deteriorates. So any solution to overcome this problem?
Yeah, that is also very critical issue for this lens design. And also, if you see the achromatic lenses, their efficiency was much lower than simple lens. And also, it cannot make high NA as well. So I have no specific solution to satisfy all these requirements. But we should compromise something. I think that we should compromise something like size or NA or focusing efficiency and so on. So it can be different between different imaging modality, like for the dual function or photoacoustic imaging or optical imaging. It has different priority.
Thank you so much, Professor. Thank you.
Thank you.
Thanks. So, Inki, there is one question in the message box, if you can.
As you when oxidation process, initial slide of microchip. Yeah. I think it was for prep, maybe. Yeah, hopefully I was right for this oxidation and reduction process. Yeah, so here the cell is gonna emit reactive oxygen, and at the same time, underneath of the cell there is a cytochrome C in the reduced states. Once there is oxygen is released, then this reduced cytochrome C will be changed into oxidized cytochrome C, right? And big advantage of this PrEP, as I mentioned, we can measure this dynamics. Reduced cytochrome C and oxidized cytochrome C, they have different absorption peaks because they have different electronic states. So these two peaks changed into this one peak. And during this transition, you're going to have PrEP peak fluctuation. So this fluctuation was an indicator for the ROS generation. So this PrEP peak fluctuation is an indicator for this ROS. Yeah. So this is the principle of reactive oxygen species monitoring.
Thanks, Inki. There is one small, it's not question, I would like to have your comment on that. You mentioned in the first part regarding MetaPret, right? And even for the case of Metasurfaces, you are using symmetric structures, right? So what's like, do you think there is a, importance in terms of nanospectroscopy for chiral sensing as well? I mean, using some chiral structures and then going for nanoscopy for the chiral applications, or there are something like this?
Yeah, there is also a very important question, chirality detection. But for this molecular detection or molecular using spectroscopy is to suppressing unwanted signal. But so the very early work on this chirality detection, people thought that, okay, we want to amplify just chirality itself. So they used chiral structure, right, to enhance this chiral interaction. But somehow this chirality signal from the structure, it was too strong. So we cannot effectively measure molecular signal. So later on, they make asymmetric a chiral structure to enhance the molecular chirality, right? So similarly, this PrEP technology, this is very useful because we measured under dark field microscope. It means we can suppress this normal reflection. This normal reflection is too strong, so we cannot detect this normal collection. I mean, bright field measurement cannot measure. I cannot see this kind of PrEP effect. Only under dark field microscope you can see these changes. So I think so. My point is, this chirality detection was a bit challenging. I'm not sure whether we can measure under scattering configuration, but once you can make it in a scattering configuration, then somehow you can see this effect as well. Yeah. So actually I have no critical solution for this chirality detection, but in principle, I think it can be doable.
Oh, okay. Thanks a lot. So with this, I would like to give a chance to participants who are physically attending the talk So if
Mhm.
anyone has some question, so
Thank
just
you.
introduce yourself in one sentence.
Thank you, Professor Inki, for such a nice presentation.
Mhm.
I am Jamal Nasir. I am a PhD student of Sir Qasim.
Mhm.
I have a question. You mentioned that you used liquid crystal material beneath the metal lens.
Mhm.
So, what was is its main purpose, and what other possible materials can we use to
Mhm.
achieve maybe more better results?
Okay, yeah. So the reason why I used this liquid crystal, actually, we focused on visual frequency, tunable metasurfaces in visible frequency. So there are not many phase change material which have, significant refractive index contrast at visible frequency. So, but actually, my colleague, he was an expert on this liquid crystal. So, and also this very well-known phase change material, right? So in the LCD display. So this liquid crystal, it can change the transmission of light by changing their molecular ordering. And at the same time, it can change the outgoing beam collision state. If the light is transmitting the liquid crystal cell, then outgoing beam collision state will be accurately modulated. So our point is, okay, if you can make these polarization sensitive metasurfaces, and if you're integrating it with liquid crystal, then by electric bias, you can make active metasurfaces. So they don't have, not many degree freedom, not much degree freedom. But as a proof of concept, we firstly showed this spin multiplexed metahologram. LCP, either LCP or RCP, if we can produce different functionality, then anyway, this is kind of electrically tunable metasurface system in the visible frequency. So if you can find, very specific phase change material which have significant index contrast in the visible, then you can make it better. But somehow I could not find yet. And also fabrication process is very straightforward. You can just assemble liquid crystal and metasurface. And also fabrication is very simple. So at the time I thought this is just optimal solution, but you can find better solution.
Thank you, Professor.
Thanks, Inki. So, is there any other question? So, I think with this, we would like to thank Professor Inki once more for sparing enough time for us. It's like more than 1 hour. So,
Okay.
thanks, Professor Inki. So nice of
Thank
you.
you, Qasim, for the invitation, and thanks everybody for attending my talk.
Thank you so much. Thank you.
Okay, thank you. Bye bye.
Bye bye.